Right, so before we do, blah, blah, get on with the talk. Some things I do. I'm a dungeon master in Dungeons & Dragons campaigns. I mentor and I teach developers. I speak at user groups and conferences. And I break production websites with incorrectly configured content security policies. Or I did in the past. This talk was written as the talk I wish I'd seen before I put it into production thinking I knew everything. So, effectively, it's a talk in 3 parts. I'm going to get everyone up to speed with what cross-site scripting is, because that's largely the biggest thing we can protect against with a content security policy. Then we'll go through what a content security policy is. Then there's a live demo where I'm going to break a website with it. And you'll kind of go through the experience that I had when I put this into place. So we'll start with the scary stuff, which is often not what you see when you see the words, the acronym XSS. It's not a scary thing for most people because, it's largely considered a joke. Effectively, it enables an attacker to inject client-side scripts into your websites. It's still in the OWASP top 10. This is a little bit dated now in 2016, but in 2016 there was a 61% likelihood of a browser-based vulnerability being found in a web application. So of those, 86% were cross-site scripting related. If you do the math, that means that just over 52% of all vulnerabilities found in this study were cross-site scripting related. In 2017, it jumped. It seemed to be growing year on year. It's not a thing that's going away because developers as a whole aren't doing things properly. So what can we do with cross-site scripting? We can put pictures of dogs in web pages. I'm a dog person, sorry. Goodbye, cats. We can alert poop emoji if we really wanted to. We can rickroll a user. Whois service was rickrolled when someone put the embed code of Rick Astley's Never Gonna Give You Up in a TXT record on their domain. So when you did a Whois search for that domain in this system, it just echoed out the TXT record without escaping. Thus, the YouTube video popped up and played for everyone. Yeah, DNS records as an attack vector is an interesting one that people don't think about. There was a self-retweeting tweet. Who was hit by that one? There was a vulnerability in TweetDeck where if this tweet appeared on your timeline and you moused over it, it would retweet it to your timeline, and therefore everyone that you had would also have the same thing, and before you know it, it retweeted itself everywhere. Back in the MySpace days, there was something known as the Sammy worm. Who was on MySpace? It's okay, you can admit it. The Sammy worm was written by someone who back in MySpace days, you could write code and put it on your profile to change the cursor into sparkly things and add colors and music and videos and all that sort of thing. And this person put a piece of code onto their MySpace profile page that anytime anyone visited his profile page, it would automatically add him as a friend, and then put the same piece of code on their profile pages. So when someone visited their profiles, it added him as a friend. He got 1 million friends in about 24 hours. He was since charged with that and wasn't allowed to use a computer for 3 years. So, real. So, okay, so maybe it's not such a joke vulnerability. Ultimately, we can do things like make modifications to the DOM, which means we can replace form actions to point to your script to capture their login or bank credentials rather than the legitimate site. You can load additional scripts in, so you can do things like put those crypto mining scripts onto websites. That was a lot of government websites and the NHS websites were hit in the UK last year with this. It didn't work all that well for them. They tried to make some money. I think they made about $26 in total. So, it's not really an effective method, but you could do that. You can access HTML5 APIs, like your webcam, your microphone, and your geolocation. Now, some of these require a little bit of social engineering because they don't automatically do it by default, but if the person trusts the website, they're on, FaceTimeWithDogs.com, and they think that, oh, cool, I'm going to be able to go on a webcam session with a dog and call him a good boy. Who's a good puppy, and then all of a sudden it's capturing their webcam and it's not talking to a dog. These are trusted websites that people can do malicious things with now. We can do some keylogging. JavaScript would be an easy way of doing that, but who heard about the CSS-based password keylogger that came out a couple of years back? Yeah, you could use CSS to keylog passwords by using some matching the end characters of what was on input fields with CSS, which would send a request to your server, and you could just log those requests and get people's passwords as they typed them in. And your standard phishing, making it look like a bank or something else and capturing their details. You can steal cookies, and therefore you can steal session cookies. There are ways to protect against this, but again, largely they're not used. So I'm going to describe something that probably sounds like something from a film. You're sitting at home, you visit a website that you trust, all of a sudden you load this page and you are sat frozen in your chair, unable to move. You can't stop what's happening. Somehow in this dystopian cyberpunk future, the computer has infiltrated your brain and made you freeze in place. It might sound a bit like science fiction, but when a headline like this appeared in 2008, it's actually a reality. There was an epilepsy support forum that was vulnerable. Hackers posted a lot of seemingly legitimate-looking threads. Each thread, when you opened it, would pop up a full-screen color image pattern, flashing pattern. And a lady, Ryan Falls, she was 33 years old. She has pattern-sensitive epilepsy. She loaded this page and sat frozen in her chair, having a seizure, unable to move, until her son pushed her out of the way. So when you consider that cross-site scripting is, I can put a poop emoji on this website and send it to my friends, there's actually a lot bigger implications. And you think about the potential leaks that we have coming up. It's no one big thing. Data breaches are everything is lost in one go. But something like cross-site scripting is just part of a much larger problem. It's not, I'm going to leak all of your data with this particular problem. It's, I'm going to kill you with 1,000 paper cuts. This is just one small problem, and I'm going to link that with another small problem, and another one, and another one. And eventually, it's all over. So, there's a few different types of cross-site scripting risks. There's persistent, type 1, stored cross-site scripting. Ultimately, the input is stored somewhere, generally in a server-side database, but we have things like local storage, which is a key value store in browsers these days. That could also be used as a method to store this. It never gets sent to the server, if that's the case. The server may not even see it in logs. Again, Whois was a site rickrolled by a TXT record in the DNS of a website, so it's not even necessarily your storage that's at risk, it's someone else's. Reflected cross-site scripting is type 2. It doesn't get persisted. It's generally you provide input to the server and it sends it back to you. If you've ever done a search on a website, you've searched for a search string, the URL comes back and you see that search string somewhere. That's a reflected risk. It's not stored. In some instances, it doesn't reach the server, which is what the next type of cross-site scripting called DOM-based cross-site scripting is all about. With single-page applications and JavaScript frameworks popping up all these days, it's increasingly common to see websites not actually even send data to the server in order to start re-rendering elements of the DOM. So this takes place completely within the browser. If JavaScript takes input, use something like document.write as a very rudimentary example, it could be vulnerable to a DOM-based cross-site scripting risk. There's another type that some people don't consider a true cross-site scripting risk. It's known as self-cross-site scripting. Ultimately, it's socially engineered. You say to someone, hey, there's this really cool code. If you put it in on Facebook, you'll get access to your friends' messages and you can post their statuses. And it requires the user to execute that code for you. So in terms of like a server-side analogy, it would be like phoning up the sysadmins and saying, hey, can you run this code for me? And they go, yeah, sure, it's fine. In reality, that's not going to happen. But because you've gone to a trusted source, if it's vulnerable, it's a lot worse. The console in a browser is an elevated level of privilege on a lot of normal things. So what a browser could normally protect, with the console, it can't, because it considers, oh, you're entering in the console. You know what you're doing. So it can't be protected. It's not considered true cross-site scripting because it requires this social engineering aspect of it, but it's worth mentioning, and I still see it as a risk that needs to be addressed. Who's ever looked at the console on Facebook.com before? You seen this? You can put messages in to say, you know, look, if someone's told you that you enter this code and you can hack someone's Facebook, don't do it. We can display messages to help stop people. Ultimately, people can still be really stupid and they'll just ignore this and think, that's Facebook trying to stop me accessing my friends' messages. I'm going to be there. Facebook doesn't know best, I do. Facebook has their problems, but they probably know what they're doing when they put a message like this in. So those are some of the risks and the things that can happen with this. So in order to access the ways in which a hacker does this, we need to embody the mindset of a hacker. We need to fight back. We have a stereotypical hacker here. There's three main key attributes of a hacker. One, there's a hood. Two, they are hunched. Three, claw-like fingers. I'm not going to mention that he's also a member of Hydra, which is terrible, so we'll skip past that. That's my friend Froggy. He's okay with me mildly talking about him behind his back. A content security policy is ultimately a response header. You send it back with the responses from your server, and it helps reduce those cross-site scripting risks. There's a keyword there in the sense that it reduces, wrong one. It reduces cross-site scripting risks. It doesn't fix them. It's not a silver bullet. We're not fighting werewolves. It's another tool to have in your tool belt to help, again, death by 1,000 cuts. There's lots of little things that you can do to help stop these particular problems. It's an extra layer of security. Security is not an absolute. Anyone who tells you that they have built a 100% secure system is a complete liar. It doesn't happen. Ultimately, it works by declaring what resources are allowed to load. Browsers are really stupid. You tell them to load something and they do it. So if you send them a page that says, hey, go to mybadsite.com and load superhack.js, the browser's going to go ahead and do that. What a content security policy does is it's a trusted header that's sent back from your application, and it tells the browser what resources are allowed to be fetched from what destinations. It blocks those pesky crypto mining things that come up, because when you go along and say, hey, browser, these are the things you can load it from me, I'm going to allow you to load Google's analytics, I'm going to trust that they can execute code on my server, so I'm going to allow those. Just as a sort of aside to that, if you have allowed anything like Google Analytics, congratulations, you've got cross-site scripting. You just trust them with it, don't you? So it'll block that crypto mining script that's been injected onto the site somewhere that says, hey, go and load this and mine me some Bitcoin or whatever. Now, with this, we're extending what is typically a server-side world of security into the browser. We can't control that. That's the users. So unfortunately, it relies on browser support, which, if you know anything about browsers, is typically good luck. We'll get it in a few years. It's been a while. It's sort of all right in terms of sort of support and what can do it. If you're still on IE, I'm really sorry for multiple reasons, but this one in particular for this talk. I've frequently been asked, what can I do if I still run IE? And I said, find a new job. That's not a correct answer, but for something like Edge, they did start supporting it. IE 10 supported the limited subset of the first version that's now deprecated. Chrome, Firefox, you're pretty good. Safari, it's not bad, it's getting there. So ultimately, there is some limitations in terms of browser support, but it's just a header. So if a browser doesn't support it, it's just going to ignore it. It's not going to break that browser because you need to support it on others. So don't limit the fact that your Chrome and Firefox users, which ultimately probably make up the majority of, in a general sense, browsers on the internet. Particular domains will have different things. Government websites, school websites, probably still stuck on ancient versions of Internet Explorer. But don't limit everyone else just because you've got a small subset that can't use this. So we can protect a lot of things. If we think about the types of content we load on our sites, we've got what's called a default source, and this is just a fallback. It says, if you can't find anything more specific, fall back to me and I'll tell you what you can or cannot load. We can protect scripts, so we can tell it what JavaScript domains it can access and what scripts it can execute from where. We can protect styles, which would help against something like a CSS keylogger, which is something that if I said to you 5 years ago, you'd laugh, but it's reality, it happened. CSS can't be used for anything except colors, but in reality, that's not the case. CSS is an incredibly powerful tool, and I really like it. I'm one of those strange people. We can protect against images. Again, what can you do with images? But if someone replaces images with your site from something obscene, if you've got a particular age demographic you're working with, that's an incredibly important thing to protect against. You can protect form actions, so you can tell the browser where it's allowed to send your data with forms, which again protects you against people trying to replace your forms with theirs to capture login credentials. And a really nice one is something called upgrade insecure requests. Who's ever put HTTPS on a website that didn't have it previously? Yeah? Who did that and then had the client phoning them because they were getting weird warnings in the browser because images weren't being served? And yeah. Well, ultimately, if you've got upgrade insecure requests, what that will do is that will instruct the browser, if you try and request, if you get told to request anything over HTTP, try it on HTTPS instead. Gets rid of all those warnings. For the browsers that support it, of course, but it really helps in that sort of thing. Now, the resource still has to be available over HTTPS. It doesn't just make it secure because it tells it to. But it's still there. It's a really nice one to help integrate this in with more legacy sites. There's a whole bunch more, and there's a full, full list of all the resources on contentsecuritypolicy.com, which is a great place to see what's supported and where. If not there, you can use the Mozilla Developer Network, which is the same thing. If you're ever looking for anything in kind of browser world, if you just add MDN after it in your Google search, it will bring up the Mozilla Developer Network, which is hands down one of the best resources for these sorts of things. It's a really nice resource to go and look at, but I'm not going to go through it all because we'd be here all day. So, if we say something like image source star, star is a wildcard. Star means allow any URL, but don't allow blob, file system, and data schemes. So if you've ever base64 encoded an image or whatever and then sent it back as a data scheme, it wouldn't be allowed with this. But ultimately it says any URL is allowed to load images. We could say object source none, which says don't allow anyone to put an object onto my page. So if, for example, you had a website that didn't use images for whatever reason, you could also say image source none, and it would never load images. Style source self says if the host scheme and port matches, I trust myself. So allow me to load things from my own domain effectively. We've got things like script source unsafe inline, which would allow us to use inline source elements. So if you've ever written an inline script tag in a template, that's possible with this. If you've used on-click attributes, anything like that, that would be available with this. Don't use it. The key is in the word unsafe. Who can spot the problem with the lock? That was at my old office building. I complained to management and they said it's fine. Just pull it out and it works. It's the illusion of security. I've got a content security policy. Cool, it allows unsafe inline. Why? Ultimately, what that means is if someone managed to inject scripts into your system and your template outputs inline scripts, it would still execute the things that have been injected in. So if you do have inline scripts, there are safe ways to execute it. In cryptography, there's the concept of a nonce, which is a number used once. Long random string that you can put in your header. So when you send back, you can say script source self and nonce dash random string. And then when you're rendering your inline script tags in your system, you can say script source nonce and the same number. If they match, the browser will trust that the content within the page matches what the header says, and it can be executed. Things that have been injected into your system won't have that nonce because it should come from your application on the back end, which is secured. If that gets breached, there's a whole other set of problems not for the purpose of this talk. Now, a question I've been asked in the past is, yeah, but if I can run JavaScript in your thing, I can just grab the nonce from your script tag and then put it into mine and then execute it. And yeah, the browser will block your script in the first instance because it doesn't have the nonce. Yeah, but if I can execute, no, you don't understand. You can't execute that first script because it won't let you. So there's always kind of the, oh, I can get around this. Not really. It's quite a nice way of being able to do inline scripts if you still need them. A full header, and this is a really small one in reality, will look like this. It's a content security policy, and then you specify all the various things you want to do. So by default, don't trust anyone. That's a pretty extremist view in security, but for our purposes here, that's what we're going to do. I trust scripts from myself and Google, because we all trust Google, right? I've got a nonce of random 123. In reality, I would generate a new nonce on every request. I wouldn't just use random 123. It's always password 123. That's the better option. Style source self, image source self. Again, I trust myself for images and styles. I want to upgrade insecure requests, and I only want to send form actions to myself as well. So here's the point where I stand in the middle. I hang my head in shame and I say, I'm really sorry. I broke production. I hope you can all forgive me. My boss did in the end. Don't do what I did. Because ultimately, if you put this sort of thing in place, you put your content security policy in place and the browsers are now being protected, and you're sat there going, cool, good day's work, Matt. Be proud of what you did. And then you get a phone call from the client and they say, hey, the website's not working on our systems. Can you have a look at it? Yeah, sure. Log a ticket quickly. Go and investigate. Close, won't fix, works on my machine. Now that's because it's a browser-based security system and I don't have the same browser as theirs. Tickets get closed, get a call about half an hour later. It's still broken, we can't do this. Ultimately, all you get is it's still broken because clients are like that a lot of the time. But ultimately, I had no way of knowing what was going on their systems. I had no way to see what was happening. So then I went and looked a bit further at content security policy. Thinking I knew it all, I just implemented it. And then I looked a bit further and I discovered a new directive that I hadn't read at first. called report URI. Now what this does is, when a policy failure occurs, it will send you a JSON payload telling you what went wrong, which is really nice, because now you've got a payload of data that says, this is what was blocked, this is what page it was on, here's the policy that was enacted, here's the time it happened, here's the browser that it happened with, and you get a bunch of information that allows you to actually debug what went wrong. Previously, I was just sat there in my office going, good day's work, Matt. I'm going to have a beer. But now I was having, okay, I can get these payloads in. But the problem was, where do I send these payloads? I didn't have anywhere to send them to. I was like, okay, now I've got my content security policy's gone from, let's implement a header to increase security to, okay, now I need to build an endpoint to capture JSON and give me a report that I can produce and see what went wrong. I did a bit more searching and found there's actually a website that had been built for this already, which is a really nice thing about working in tech, because if you've got a problem, chances are someone solved it before. It might not be great, but chances are there's something. But Report URI was written by a guy called Scott Helm, who is incredibly knowledgeable on this topic and an incredibly friendly person. I've spoken to him a few times about it. But effectively, it gives you an endpoint that you can put into your policy, you sign up for an account, and you can send payloads to it, and you get charts showing you, these are all the things that went wrong. So I've got, okay, script source, discuss was blocked. There was some evals somewhere that were blocked. And I looked at this, and I was kind of like, something's gone a bit wrong there. In this instance, the way LastPass worked at the time is it would effectively inject JavaScript into your sites to be able to autofill its password manager, and my content security policy was then blocking LastPass. So the client telling me that the site was broken was actually, I can't use my password manager. I would have had no way of knowing that because I don't use LastPass. But now with these reports, I could look at it and actually see what went wrong and start putting things in place to fix that. That's great. I've got a report saying it went wrong, but ultimately the browser is still broken. It's still breaking, it's just telling me about it now. So I did a bit more reading, and I found out about a header which is report only, which is really nice because it effectively says, if something fails, don't block it, allow things to keep working as they did before, but send me that payload to tell me what would be broken. So I still get the same payloads, but now I don't actually have to worry about breaking the site. So you specify it the same as you did before, just with report only. And what this does is it allows you to trial things before you enforce them, which for something like a content security policy, which has the chance to break without you realizing how it could be broken, is really quite an important thing. Again, I wish I'd known this before I put it in place. But this sort of thing really helps with actually, okay, now I can start pulling in reports. I can leave this in production for a month, see what kind of reports I get. I can fix those before I start enforcing the policy, because in a month I'm probably going to get a good idea of what kind of traffic is coming, what kind of browsers are used. Unfortunately, that means there will be lots and lots and lots of noise, because logs. Imagine that every request on your site, something is broken. Every request you'll get a log in report URI. To give you an idea of scale on this, who's used or heard of Envato before? They're a fairly big, they're like Alexa Top 500, I think, at one point. They sell WordPress themes and things, I believe. They pointed their content security policy at report URI and deployed a policy that was broken. And at peak traffic with that, because of the amount of visitors they were getting, Scott Helm was seeing something like 45,000 requests a second across 4 load balancers, each load balancer. So he was having something like 200,000, almost 200,000 requests a second because of all the various things that were broken. It was just... So that was a fairly big scaling issue for him pretty quickly. But ultimately, it's the kind of thing where just be a little bit careful with it. So now we get to the slightly dangerous part, where I'm actually going to quickly switch over, fire up a local site that I've got, and we'll go through the process of talking through the site and what we can do with it. So, cool. Can everyone see my screen? So, we have a website. We, as a very large development team for a very small site, have been commissioned by the Ellingson Mineral Company, who clearly have too much money, to build a website for them. 10 points to anyone who knows where the Ellingson Mineral Company is from. Yes! Hackers. The greatest hacking film of all time. If you haven't seen it, your homework is to forget everything I've said here and go and watch it, because that's more important. No. So we've been hired by the Ellingson Mineral Company to build them a corporate marketing website. We've got some very business corporate speak. We were professional. We used a business Ipsum generator to generate us some goalposts we need to recap by end of day and get buy-in. These are the kind of business words that they like using. We've got a few important pages. We've got a home page where they've got their logo, they've got some styles, things going on. They've got a page for the Gibson, which is their all-powerful mainframe supercomputer. And because of that, they really need their customers to know that, there we go, that this page is totally secure. So when we access it, we need to let them know that the page is secure, and the marketing team decided the best way to do that is with an obnoxious pop-up that tells the customers this page is secure. So that's what we do. We put in an obnoxious pop-up telling them that the page is secure. And we've got another place. We can also see that the Gibson is really important because it's got this like holographic file system. We all know this is what computers look like on the inside, and we need our customers to know this as well. That's how they know we're serious business. There's flashing lights. We have a place to put some garbage files as well, which is just a place to store notes on the site. We need to just put some text in, and that's what they've decided they need. And again, we need a message that lets us know that the files are secured. So if we go in and we put a note that says hi there, we update our note, we can see that the note says hi there, and the files have been updated. Now a hacker comes along, and they look at this, and they see a couple of interesting things. One, they see that in the URL bar, we've got this message here that says secure message, files updated. And they're there, and they're typing, and they think, I wonder, okay. So that message that I've got in the URL bar displays in the template for me. So they look, and they think, okay, if I run a script, live typing. What should we do? Should we alert something? They already have alerts on the website, so if we alert something else, they'll know that, maybe it's meant to be there. So let's, alert poop emoji. Let me just copy that quickly. And we load the site again. Hey, alert poop emoji. So now as a hacker, we've actually discovered there a reflected cross-site scripting risk. We've sent a request to the browser that included this content. It's been reflected back to us, and we've now got it displayed in the browser. Ultimately, once it's gone, if we go back to the page through another means, it's no longer there because it was reflected on that request-response cycle. But we noticed that the content we put earlier in the note is also on the page. So the hacker thinks, I'll be smart. I'll alert poop emoji. And we update the note, and we get poop emoji. But now the difference is this is stored, so every time we go back to the page and we reload it, we get poop emoji. So now they've found a stored cross-site scripting risk on the site. So that's potentially interesting, because every time someone loads this particular page, they would get the same thing happening. Now this is just a really simple example of alert poop emoji, but ultimately they could do a number of things with this website. So this happens one day. Customer phones up, Matt, you need to fix this problem. There's a poop emoji on the website, and customers are losing all trust in us as a company. We had a pop-up telling them we're secure, and now we've got a pop-up with a poop emoji. It's awful. Matt, you need to fix this. I know. I've heard of this thing called a content security policy. Don't worry, client, I can fix this for you. We can sort this out. I don't trust anyone. I can fix this for you, client. Bam. Oop, nope. Why aren't you working? Oh, damn it. This is not fun. I'm going to blame delegated volumes on Docker. Effectively, what would happen is this page would load, and there'd be nothing. You'd have your text, you'd have no images, no styles, no scripts, because you've said to the browser, I don't trust you. Oh well. Nothing would load. The browser says, I don't trust any of you, because you've asked me to request images from myself, I don't trust myself. You'd ask me to request styles from myself, I don't trust myself. You've asked me to request scripts from myself, I don't trust myself. And now when they're loading and looking around the site, I'm going to try. Nope, same thing. Effectively, what would then happen is, client phones up, says to me, Matt, cool, thank you for fixing the poop emoji. There's no poop emoji anymore. Unfortunately now, the clients don't know it's us because it's a white page with black text. There's no logos, there's no images. They can't see our amazing supercomputer, the Gibson, at which point you kind of say, okay, yeah, I'm really sorry. What we end up doing is we develop this further. Now, through the process of everything we do, we say, okay, I'm going to allow scripts from myself. So we say script source self. We could say none. If we said I don't trust myself with JavaScript, what would then happen? The poop emoji wouldn't load. Unfortunately, we have a template with on the Gibson page, which includes our super important pop-up that says the page is secure. Now, ultimately, that wouldn't load. The client phones us back, Matt, this is amazing. We've got styles, we've got images, that's really cool. Our clients don't trust us anymore because the pop-up isn't telling them that we're a secure company. And you say, okay, I'm terribly sorry. I can fix this. We then allow unsafe inline scripts, which causes this to execute. But what that now means is, within the browser, when we visit the garbage files page, if we look in the source, we also have our notepad script that says alert poop emoji. Now the browser's been told that's okay to execute because it's an unsafe inline directive. Again, the keyword is in the keyword's in the directive. It's unsafe, but we've allowed it, and it says, you know what, I can use that, and it executes this script. What we can ultimately do is we need to, as per the talk, we add a nonce, which is a attribute on our script tag. Within your templating language, add however you like. For me, I mostly use Twig, so what I do is I add a global variable to Twig so that it's available in every template I've got access to, and I can just call nonce and it outputs my nonce tag for me. The reason I often do that is to try and reduce the barrier to entry, because we're developers, we're lazy. If something takes more effort to do, we won't do it. So if you can reduce that barrier to entry, then there's no excuse for not doing that particular thing. So there's a few tips when actually implementing these particular things. You need to have an easy and quick way to disable the CSP in production if needed. I'm evidence of that because thankfully I could roll back our deployment, which was really, really helpful. I was able to deploy the last commit, it rolled back the system for me, got rid of the content security policy, and the site was working. That was really nice. What I wish I had, in reality, was a way to switch from the enforced policy, which was breaking things, to the report policy, which was actually giving me the data but not breaking anything. Because the scale of this, with it being browser-based, those reports kind of prove really useful in what you're doing. If you need a nonce, then I would add the CSP at an application level. So if you're using a lot of modern frameworks that use middlewares, we've set up middlewares in our applications to add this to the outgoing response. Those middlewares have access to our dependency container that has our nonce generator in that effectively generates a nonce once on every request and then stores it for us. We can then use that. It stores it in memory. But that's now available to our templates as well as our middleware that sends the response back. So that gives me the ability to put the same nonce in the template as well as the response header as well. If you don't need a nonce, you could absolutely add your content security policy at Nginx or Apache level, for example. There's no reason why you couldn't put it in there. If you do use a nonce, don't generate multiple nonces in the same request, but you do want to generate a new one on every single request, otherwise they're guessable. If you don't generate a new one and you do it once per deploy or whatever, then I can just keep using the same nonce until the next deploy. If you're using a templating engine like Twig, add it as a global, again, just so you can get rid of any barriers to, oh yeah, I was going to put the nonce in, but then I realized that I need to add it to the template parameters in my action, and that's just too much effort, and it's just more work every time. Just add it globally. If you need to, write a helper in your templating language of choice that can output you your script tag so that you never forget the nonce. That's even better, because then you can't forget it. You can have multiple policies. This is really useful. It's problematic if you have multiple enforced policies. So for a resource to be allowed, if one policy says I'm going to allow scripts and one says I'm not going to, the browser will block them because one has said I'm not letting this happen, so the browser blocks it. However, they are really, really cool. So avoid them for enforced policies, but for reporting policies, they actually allow you to have a policy that's enforced that will break the site if anything goes wrong. But it shouldn't be. It would only break the site for people trying to do malicious things. And you can have, if you're saying, actually, I think I can either tighten this policy or I need to make some changes, but I'm not sure what the impact of that will be, you can add a report policy. Now, your report policy will send you all the things that have failed on the new thing that you might do. So you can say, okay, I'm going to start restricting images. I previously allowed images from anyone, but now I'm only going to allow them from myself and another third party, Amazon S3, for example. So now that means that if something does come along that tries to put in separate images, you'll get a report for it, but it won't break the site for that. Which means you can put this in place, let it run for a couple of weeks or whatever, gather your reports, see if you need to change anything, and then redeploy it. So it's really, really helpful because nothing changes for the user, but for you it gives you a lot of information that stops you breaking things. I would recommend, if you do want to learn a bit more about this as well, go check out Scott Helm. He really knows his stuff on this one. He runs Report URI. Who's heard of Have I Been Pwned before? And Troy Hunt, the guy behind it? Scott's partnered with him on Report URI, and Troy Hunt's now involved in the development of it as well, which is cool. Report URI previously was free completely. It's now a paid service, but you do get, I think, 10,000 requests a month for free. After that, it's like maybe $10 for like millions, maybe. But for the sake of, you don't have to write and maintain this system yourself, and it does all the graphs and dashboards, it's a very low cost in the grand scheme of things. Another person is a guy called Mark Goodwin. He introduced me to content security policies back in 2014, I think. He gave a talk at my local user group, and I looked at it and went, this never ever occurred to me. 5 years later, I'm giving a talk, and it still seems to be something that's not widely used, which is kind of a catch-22 because people say, oh, I'm not going to use it because it's not implemented in the way that it should be everywhere. And then browsers say, well, it's not many people are using it, so we're not going to implement it. And then you end up in this nice little cycle of someone saying, I'll do it if they do it, and then someone else saying, I'll do it if they do it. So it's kind of taking that, not like a leap of faith, but just taking that step to say, I'm going to put this in place. Ultimately, older browsers that don't support it, they're not going to be affected, so you're not going to cause problems in that regard. There's a whole bunch of resources if you do want to learn. I mean, the OWASP stuff is something that, this XSS has been in OWASP since, I don't know, I can't remember, it's always there. It doesn't go away. ContentSecurityPolicy.com has the references for all the directives that you can protect. You can do some really wild things. Report URI is the website for capturing those requests. I posted the blog post of just how much traffic can you generate using a CSP. That's the post that Scott listed after, hey, we basically got DDoSed by a security system. The stats report, the demo is written in Slim. It's just a small Slim application. Again, it does it with a middleware. It adds the policy as a middleware to the application and sends it back. I think, in reality, I know why it wasn't enacting. I can fix this, everyone. I will show you. Let's have a look at our config. Where are we? Haha, there we go. If I enable the middleware, then things break. There we go. Oh no. I promised you breaking things, didn't I? There we go. Right. So that's what happens. When you say, I'm not going to allow anything, you get nothing on the website. I didn't quite do it that drastically. I'd effectively said, you know what, I'm going to not quite allow nothing. But that now means that when we navigate around our site, we've got our Gibson page, but again, there's no images, there's nothing. So then we say, okay, I'm going to allow image source self. There we go. So we get our images back. I'm then going to say, you know what, I'm going to allow styles from myself. So I'm going to allow styles from myself, which again means we get our styles back, but we don't have our obnoxious pop-up. So when we say, you know what, for my obnoxious pop-up, I'm going to give in to the client and we'll allow it. Okay, we'll allow them to keep their pop-up. We're going to say script, source. Let's do our unsafe inline, because, you know, even though it's unsafe, we'll allow it. We get our obnoxious pop-up back, but again, the problem is that with our garbage files, we don't actually protect against anything. So that's when we can kind of go back and say, you know what, I'm going to put my policy in place. This is a default one I've written. My script source, I'm going to put in my nonce, which for the purposes of this is generated elsewhere and just kind of put in like a template. Which now means that in here, style source, self, nonce, those are fine. put our styles back in and our scripts back in. If we say on the safe inline, we get it, it runs, we get the problem. However, if I now say, you know what, I'm going to trust myself, and I'm going to have a nonce we have that working. In our Gibson, we have the nonce added, so it knows to execute that. We can still get our obnoxious pop-up. That's cool. Clients are happy. Obnoxious pop-up is still there. Marketing wins. But in our garbage files, we don't actually get anything displaying because that script that we've injected doesn't have that nonce. It doesn't know how to access that. If we look at our network tab in our console, we've also put in a message like Facebook, stop, please don't do anything in here. You know, Facebook knows best, we'll copy them. And we get a couple of content security policy violations, effectively, saying, hey, this page blocked a script. We're not going to allow that to happen. Which now means that we've avoided the hackers. We've got our obnoxious pop-up. We've got our images of our amazing supercomputer with the flashing lights and the things going on. And it now means that we can continue working. The client's happy because they've got their pop-up, they've got their images. We've blocked the hackers. A little bit of stress from our behalf because we broke things at the start, or didn't break things, as the case may be. But what that now means is that we've started bringing the security of ourselves as developers into the world of the browsers, which is only getting better and better. We've got things now like sub-resource integrity. So when you load a script from an external resource, you can give it the hash of the contents of that script, and you can say if the contents don't match this hash, don't execute. Which is cool because it now means that if you've trusted some CDN to load jQuery, for example, what happens if that jQuery got modified to be malicious? You're just trusting that that external site is valid. Now you've got scripts that you think are trustworthy executing on your site that have been compromised. So we've got things like that being put in place. We've got additional headers now coming that are going to do things like allow you to declare what JavaScript APIs can be used by the site. So if you know that you only use a subset of JavaScript APIs, you can send a header to do a similar thing and say, you know what, you can't use this particular feature within JavaScript. So even though it's slowly building, it is growing, the use of it is growing, the support is getting better. And in a world where it seems like every other day 500 million people have had data leaked by some big company that doesn't give a crap, security is becoming more and more of a thing, and the browser's just pushing this is just going to be a nice way to do it, because for the users, if you do it well, it's kind of invisible. So, thank you for putting up with me for 45 minutes of rambling on. If nothing else, learn to recognize hackers.
Okay, Matt, thank you. We have a few questions for you,
Cool.
5 actually. Can you define a normal CSP and a report-only CSP at the same time, so you can report some things but block others?
Yes, absolutely. Multiple policies, as I briefly covered, you can do that. What that means is if you've got a policy that you know is working and you want to improve it, you can put the new policy in place in report-only mode, which will tell you things that would go wrong, but in reality, they're only being sent to you, and you can kind of log them and then work on that and then do it again and kind of keep going. You're never going to get it right first time. It's just not going to happen. So that's where the report-only mode really helps, because you can get those logs and be a bit more iterative about it.
Okay, next question. Preferred way of setting up CSP headers, Nullmio security bundle or Nginx Apache configuration?
Typically, I've always done it in the app, so be it in the security bundle in something like Symfony or in middlewares. I typically always do it in the app. I just find it a bit easier to configure for the developers if they need to change it, rather than having to go digging in web server config, which is always way too easy to get wrong and then break things even worse. So I typically just do it in the app. It can be done either way, but I'd recommend inside your PHP code.
And in the notes, you
Definitely in the app. You can do it in Nginx. I've seen the weird templating code to do it, but you don't want to. It was like a horror story. I was just like, I don't want to see this ever done. But it's possible. Don't do it. Just do it in your app.
How can you work with a nonce in a single page application?
Right, so single page applications can be a little bit tricky. Ultimately, once you've got that initial JavaScript executing, it should be okay, because that JavaScript can load in additional things as it needs to, and they should be fine as long as they're not trying to re-render like inline scripts. It should be okay. If you're just pulling in other files in bundles or modules or whatever, as long as they're from trusted places, it should be fine.
Okay, in which way is nonce validated?
In this, if what sort of context is behind it? Something like that.
Oh, well, it's in which way is nonce
Right.
validated?
I don't know the exact context behind that, but effectively, what the browser does is, if you've got a nonce of a random string in your header, and you've got a script tag that doesn't have that nonce, the browser will look at it and say, I've got a nonce in the header, and I've got whatever other directives are there. This script tag doesn't have a nonce, I'm going to block it. If it does find a nonce in that tag and it matches, it will effectively just compare the two strings and say, are these two strings equal? If so, I'm going to trust that this script tag came from a place where it can be trusted, and it will run them. It's literally just a basic string comparison on them. But you need to do that, generate a new nonce on every page, because then it is a random number used once per request, effectively.
And the last one is...
Sorry, if I haven't covered that, grab me after the talk and I'll chat through it with whoever asked that.
yeah, that's the open.
Oh, okay.
Open season for you. And last question is, what about the case of a last pass you mentioned? How can we leverage such user-specific script injections?
So browsers have also updated slightly on this one. Extensions in like the last pass one was an extension in the browser. They again have an elevated level of privilege within the browser. They can do things that JavaScript on a page can't, for example. That's why when you install them, it basically says this particular extension can do whatever it needs to. It can read your browser history. It can redirect you. It can do all those things. You kind of have to trust those scripts. Browsers do pretty much allow that now. If you're allowing users to inject JavaScript onto your site to be able to have kind of that MySpace type thing where they can inject that, it's possible. You're going to have to do 1,000,001 other levels of validation on what is happening with that particular thing. But that could be an area where you could say, you know what, I'll let you do it. And with the new headers that are coming for what JavaScript features can be used, you could limit them to a subset of features, for example, as well.